Good morning. I welcome you all to this first lecture of Foundation Engineering or Geotechnical Engineering 2. And in fact, many of you might have attended my first course Soil Mechanics or Geotechnical Engineering 1, and I was also requested for this second course of Foundation Engineering, and because of that I have again taken up this course, though I have a bit too much difficulty to do it, but for the benefit of you I have taken this course in this time. And as I have told you that in the civil engineering, out of 5 sections, geotechnical engineering is one of them, and in that 2 major courses, one is soil mechanics, another is foundation engineering, and sometimes it is classified as soil mechanics or geotechnical engineering 1 and geotechnical engineering 2. So, foundation engineering is under we can say geotechnical engineering 2, and also I have mentioned that soil mechanics is the foundation of foundation engineering. This is a very important that to learn foundation engineering you need to learn first the soil mechanics. I hope all of you already completed this course, and this the foundation engineering again we have basically under foundation engineering means what actually below the earth, whatever infrastructure we do, that actually comes under foundation engineering. This can be of the footing of a building, then it can be a earth dam, it can be an embankment, it can be a earth retaining wall, it can be a retaining wall, or just flexible retaining wall, or it can be similar tunnel, it can be, but of course, tunneling is a very advanced subject, and we may not be able to cover under this, but otherwise other type of foundation problem like foundation for buildings, then again there are different types of foundations, then there will be earth retaining structure, then deep excavation, then little bit of vibration, that will be foundation for dynamic loading, we will cover under this course. And of course, as I have told you that your soil mechanics is the foundation for foundation engineering. So, I hope all of you taken, but once again before going to the foundation engineering, I just quickly review the soil mechanics part, mainly because that some of the things I will be used frequently, but we may not able to discuss in length, and so that so you should not have any difficulty. Because of that, what are the important aspects very frequently used and which we may not able to discuss in length, that I am thinking of taking very quickly. And so that first week mostly I will devote on quick review on soil mechanics, and this. So, first slide will be I will be of course first session or first module I will be covering this, that is origin. That means in the foundation engineering first step is to understand the soil, and understanding of soil can be done in different ways, and of course, full understanding cannot be done by a single step. There are various ways of understanding, and one of them to understand the soil is seeing the origin. That means, from where the soil is originated, it will be original from the rock, and what was the parent rock, and what was the agencies or what is the cause the rock modified to soil. If we can go through that, then sometime we get lot of information. For example, if it is from organic source, that means if the soil is formed from the organic matter, then that soil is generally is a very difficult soil and we have to take care of it properly. Similarly, some soil will contain some of the chemical parts which can actually react and it behave totally differently. So, and that we know from what is the source that type of soil originate. So, that is what that if you know the origin, sometime we will be able to get some of the behavior of the soil. So, origin is the first step, one of the way we can, one of the ways we can understand the soil. And then again classification, the second step is the classification, and this classification again soil can be classified in various ways. For example, as I have mentioned that based on origin soil can be classified, based on grain size it can be classified, geologists also classify the soil one way, then engineers also classify the soil another way. So, like that there are number of ways the soil can be classified, and but we need to know only engineering classification and which actually universally used across the globe. That means, if the soil is classified by some name, then every engineer, civil engineers should understand what type of behavior the soil can have. So, that is the one, that classification part also I will be going through very quickly, because this is also very important. And then another third aspect, that is weight volume relationship, that is actually the soil is a 3-phase system. That means, if I take a mass of soil and if I assumed or idealized and draw a diagram, then we get a 3-phase diagram, and that 3 phases are what? One is air and water and solid, and based on that we could define, give a number of definition like void ratio, porosity, degree of saturation, water content, all those things, and how they are related to some of the important parameters of soil like unit weight and all, that we will also discuss quickly. And then another very important aspect is that effective stress, and very frequently actually we will be using this in the foundation engineering various calculation, and this effective stress though looks very simple. That means effective stress is what actually, that means if I consider a point at a depth of suppose 3 or 4 meter or 5 meter, and what is the effective stress I want to find out, then actually entire weight above that point to be considered, and if I consider unit weight, then that weight divided by unit weight will give you the pressure. That is a simple understanding of pressure, but when the soil is under water, that means when the water is saturated, soil is saturated by water table and all, then what will happen, because of this head of water there will be your pore water pressure, and pore water pressure it will act in all direction, and because of that we can calculate the effective stress, whatever the total stress minus the pore water pressure, that become the effective stress, and that effective stress is very important in all calculation, almost every calculation, because strength and all related to this effective stress of the soil. So, that part again it looks very easy, that means unit weight multiplied by depth, that is your total stress, and then unit weight of water multiplied by depth of water table at that point, and that difference of these two is effective stress. It looks very simple, but still we have seen from our experience that students frequently do mistake in this, and so because of that I will again explain this part and quickly go through some calculation, so that you do not have any problem in future. Then another most important perhaps the shear strength, and shear strength actually ultimately the soil has to take the load, and when you apply a load, then and it will be soil will be stressed, and if the strength of the soil is less than the stress applied by the external load, then soil is going to fail. So, that means to prevent failure you have to ensure that soil has enough shear strength. So, that actually that means we cannot actually shear strength of the soil cannot be changed. Actually, it is that is actually in the natural form, whatever form the soil is, that in that form you have to characterize the soil, and based on that characterization, and you have to find out the strength of the soil, and then finally, while designing the foundation and other infrastructure which will impose the load on the soil, you have to make in such a way that the stress because of this will be much below than the actual strength of the soil. So, that is the way, that means everything ultimately our aim is that build something, but it should stand, it should not fail. So, to make sure that you have to estimate the shear strength, and there are various methods, and of course, foundation engineering it is we need not discuss in length, but some quick review we can do on that on shear strength. And at the last but not least, the most important parameter is the compressibility of behavior of the soil. What is this compressibility behavior of the soil? Actually, when you build something over the soil, and then soil will be stressed, and when the soil is stressed, then obviously as you know the soil is of three phase, that there is a air void, there is water, and also soil can be treated as a elastic material. And when the elastic material, if you apply load, either when you apply tensile load it will be elongated, when you will give compressive load it will be shortened or compressed. So, soil most of the time will be subjected to the compressive load, and then settlement will be compression most of the time. The soil will undergo actually the settlement under loading, and that settlement will be consisting of several things. One is actually the elastic property of the soil, that is called elastic settlement, which takes place within some day or two, and there is another settlement called consolidation settlement, and which is actually a phenomena for fine grained saturated soil, and that of course, mechanism and everything we have discussed, but some calculation quickly which will be frequently used we will review again. And there is a third type of settlement, that is because of creep and secondary consolidation, that is also there. So, altogether there will be total settlement, and that settlement actually depends on the compressibility behavior of the soil. Different soil will have different behavior, and of course, when we build something on the soil, and then as per codal provision we restrict the settlement that particular, for example, for a common building the settlement should not exceed suppose 25 or 30 millimeter. And why this restriction? If you have excessive settlement, there can be several problems. There may be likely problem of in the building, and that to prevent those problems generally you have to restrict the settlement. Not only settlement, sometimes the building may have a number of foundations or footings, and different footings may have different loading also, and because of that loading sometimes different footing will settle differently, and that cause actually some differential settlement. So, all those things actually comes under that restriction in differential settlement also is there. So, all together the compressibility behavior of the soil. So, that also will be very quickly we will review. So, next let me go to the next slide, that origin we want to see, that is your this slide actually I have also used in soil mechanics. You can see that the soil before forming the soil originally that the earth was in the gas form, and then under cooling, and here you can see it is written 4 to 5 billion years ago it was in the gas form, and then subsequently it become molten magma, and then from there under cooling it become igneous rock. And this igneous rock you can see then after weathering or some other effect it become residual soil, and again from the residual soil again by under heat and pressure it can again form like a rock, that is metamorphic rocks. and again directly from residual soil. You can see from residual soil residual soil directly again under transportation or weathering, it can be form a sedimentary deposit, and from that again sedimentary deposit that can be treated as soil, sedimentary soil, and that sedimentary soil again under compaction cementation it may form sedimentary rocks. Again sedimentary rocks can by weathering and transportation it can become sedimentary deposits. So, like that this cycle also continue, and again from residual soil by heat and pressure it become metamorphic rock, and again by different processes you can see it can either become sedimentary deposits or it can become sedimentary rock, and again sedimentary rock too again heat and pressure it can become metamorphic rock. Like that entire process will continue, and finally the rock masses will be decomposed into small fragments, the particles, and then when it become that particles that we will treat as soil. And then the different rocks, again a rock will have different minerals, and based on that from which rock is originated, if I know, then sometime we will be able to characterize the soil to some extent. So, that is the reason why I want to review on origin of the soil. And now you can see that rocks, as I have mentioned, that rocks made of different minerals, made from various types of minerals, and minerals are substances of crystalline form made of from a particular chemical combination, and the main minerals in rocks include quartz, feldspar, calcite, mica. There are many, and we get frequently in the soil this type of minerals. And as I have shown that there are three different types of rocks, that igneous, metamorphic and sedimentary and metamorphic, and again further by different chemical or weathering effect the rocks deform or into small particles, and that become the soil. And under that you can see igneous rock, there are important igneous rock, you can say there are it is granite, basalt, gabbro, they are all used in building various building activities, like granite and basalt will be used in railway tracks and many other places. And similarly there are many other use of this igneous rock. Sedimentary rocks are under this actually shale, sandstone and chalk, and metamorphic rock, slate, quartzite and marble. And you know the marble, one of the very important building materials we use for various decoration purpose, flooring purpose. And so, these are the three important rocks which are also used in the building activities. But our interest is not the rock, actually from the rock when finally transform into soil, and then what the soil contains, that actually we want to see, and then based on that we will characterize. So, what is the definition of soil? Definition of soil actually you can see that the action of frost, temperature, then gravity, wind, rain and chemical weathering are continuously forming rock particles. That means initially rock mass, and then from that to rock particles, and that rock particles is eventually when become smaller and smaller become soil. And there are three types of soil when considering mode of formation, modes of formation. That means, as I have told you that different agencies are there, how it transform from rock to soil, and because of different mode of formation we can mainly divide this into three parts. And you can see that next this one of the example I will show here, I am showing here that when the river flows, actually suppose the direction of flow is this, if the river flows in this direction, then what happens, actually this is our upstream side and this is downstream side, and then when river flows and velocity is high, then what will happen, this is, suppose this was the original ground or rock surface, and then while flowing this this flow of water will cut this portion of rock and it will be rolling or flowing with water, and when it flows along with water, then it will be trying to, it will try to deposits when the velocity will be reduced, and that what will happen, when it will happen, it is towards the sea. When the river meets sea, the velocity will be reduced significantly, and then it will try to deposit those particles, and you can see that higher reach comparatively coarser particle will be deposited like sand and gravel, and when go to the close to the sea, the finer particles like clay will be there, and before that silt will be there, medium size particles. So, this is one of the example that how soil rock is transformed into soil, and this is called transported soil. That means, while transporting, the rock mass is transported by water and it is deposited in different places, and then soil is formed. So, all those, whether it is sand, gravel, silt, clay, all together are soil, because when the particle size is becomes smaller than something, then we treat this as a soil. Again, soil can be sub classified as gravel, sand, silt and clay, all those things, but otherwise this zone is whatever deposited, that is entirely called as clay soil. So, let me go to the next slide. Suppose I have mentioned that based on modes of the formation, that it can be classified different name. Actually, this is transported soil. There are number of them. I can you can see mentioned here. Aeolian soil, that dunes and lows by that is actually formed by wind. Particularly, this type of soil will be available in desert, that the particles will be rolled over because of the wind, and they will form a ridge and like thing, and the way the soil deposited, the sand particles, they are in a very loose form, actually that is not compact. So, that this type of airborne soil, transported soil is name actually typically known loess. Similarly, colluvial soil by gravity, because of the gravitational action, if the rock transform into rock soil, then that is called talus, that is a colluvial, and specific name is talus. Similarly, alluvial soil, when the water is transported by water and deposited as a soil, then that is called alluvial soil. Similarly, glacial by ice and snow, and residual soil, there is another mode of formation, residual soil, that means laterite and saprolites, that is because of the chemical weathering, that means the rock mass, because of this chemical weathering, the rock mass transform into smaller particles and deposits there itself, then that can be considered as a soil, and that soil will be called as, typical name is laterites. This is a specific name for laterites and saprolites, but based on mode of formation, if you classify, this soil will be classified as residual soil. Similarly, there is third mode of soil formation is organic, as I have mentioned beginning. If the soil is transformed or formed from the organic matter, and then that is called peat. Of course, it is a peat is a very special form when the organic matter is fully decomposed and it become like a fine clay particles, then only it can be called as peat. Otherwise, it can be different form of organic soil, amorphous and all. I have discussed those things in detail in soil mechanics. So, this peat is a very special form of organic soil, and you know that if there is a peat at a particular site, that the soil is problematic, that it will undergo huge compression. So, because of that, if you find at any site a peat type of soil, then you have to be very careful while designing anything. So, this is about the classification based on mode of transportation, and similarly there are other classification will be there. Engineering soil, engineering broadly we classify the geotechnical engineering as cohesive or cohesionless soil, and sometimes we also classify as granular soil, or this is actually sometimes we say cohesive soil, another is cohesionless or granular soil. Another way we classify as coarse grain and fine grain. Okay. So, this is the way we can engineering classification we do, and under coarse grain you can see the two types I have mentioned here, gravel and sand, and under fine grain actually silt and clay. And again in the clay soil, this is the finest particle in the soil, and it can contain different clay particles, and the most important clay particles which we find, there are many some more, but kaolin-illite and montmorillonite, and they have a definite characteristics, and if you find this type of clay minerals in the soil, sometimes some soil will be problematic, some soil will be not problematic, and if you find that is a problematic soil, obviously you have to take care while designing the foundation. Because of that I am trying to bring this briefly here. And then soil versus other engineering material, that means you can see steel and concrete, when you consider building materials, then you can see that steel and concrete manufactured can be produced with desired strength and stiffness, and quality also can be monitored, whereas soil is actually naturally formed and properly mostly not known, or sometime after knowing many things we can characterize, but it depends on many factors. Because of that, soil is very important, that you have to understand the soil before doing anything, because not like other civil engineering material that which can be manufactured with proper quality control. The soil actually formed naturally. So, there is no control over that. Whatever we get, we have to characterize and we have to assess their properties, and we have to get their strength, compressibility and all before going to designing the any foundation system. And then soil characterization again consists of these things: permeability, compressibility, shear strength. I have already told, I will not go in detail on that. The permeability, one of the important property, that how porous the soil is. If the soil is more porous, then water will move first. If the soil is very less porous, then soil will not move, and soil movement through water is dangerous. That actually you have, that aspect you have to take care. And then of course, there is a when there is always civil engineering, civil engineer professionals generally before build anything, they have to go to the site and they have to assess the soil type, of course without any equipment in hand. So, at the site, based on some physical examination, we can assess the type of soil. So, that actually I have done in soil mechanics also. You can see that the sand, silt and clay, out of these three particles, if you can identify properly, we can get actually lot of things. So, because of that, how we can identify sand, silt and clay in the field, that is listed here, that when it is sand, individual particles are visible, whereas silt, some particles are visible, mostly individual particle will not be visible, they are so fine, and for clay not at all visible, silt sometimes partly visible, and sand exhibit dilatancy. That means, if you make a fine soil, particularly if you make a paste and put on your palm and make a pat on it and then shake like this, then you will see the water will come out and it will be shining. And when it is sand and silt, both of them will have this property, whereas sand it will be easily, whereas for silt you have with difficulty, by shaking you can see the water on the surface. Otherwise, both will have this property, whereas and clay will not, no dilatancy will be there for clay. Actually, if you make a paste and put it on our palm and then shake it here like this, then we will not feel anything on the, we will not see any water at the surface. And then when it is sand, in the lump of sand, if you take, easy to crumble and there will be individual particle will fall automatically, whereas silt also easy to crumble and can be dusted of hand. That means, when it will silt, if you take it hand, your hand will be dust, will be dirty, but this dirt can be cleaned easily by doing like this. If you do like this, your hand will be cleaned, whereas if it is a clay and if you make a paste with water and then break it, then some particles will be stick to your hand, and after dusting off your hand, it will not be clean, you have to wash it. then only you will feel that there is a clay contents are there. Similarly, if the sand if you take between fingers, you will feel gritty, and whereas silt if you take between fingers and rub, then you will feel rough. Rough and gritty, there are difference, and when you become a specialized engineer, you have to have that feeling. Similarly, if it is a clay soil, if you rub between the fingers, you will feel very smooth. Actually, there will no neither any gritty feeling nor any rough feeling, and whereas if it is a sand, then no plasticity, that means you cannot roll it like that, and whereas silt, that means you can make a you can roll it, but very thick diameter you can make, whereas if the soil contains clay particles, then you can make a very thin rope thread like by rolling. By rolling like this, if you can make a very thin wire like things, then we can surely understand the soil contents clay particles, whereas if you cannot make at all, then you can sure that the soil mostly sand. So, this is roughly your field classification, that means the field, when civil engineer goes to go to the field, but just by visual inspection and doing this few physical thing, one can assess the type of soil present in the site. So, this is one quick review of part 1. I just I will take next actually engineering classification, that means how we can further classify the soil, that is actually qualitative classification, based on which we can understand whether soil contains sand, clay or silt, whereas to assess the strength and other things we need to know many more things, and we will subsequently discuss about those classification in the next slide onwards. Thank you.